Okay, so welcome back to another video. So here today we have today's video is going to be a short one and an easy one by that, and we want to show that the following verification that cosine square of x plus sine square of x is equal to 1, but we will be using this, we will be proving this by differentiation, otherwise known as the Fundamental Theorem of Trigonometry, or you can call this, or also call it the Pythagorean trigonometric identity, which we all use in when you're dealing with trigonometric identities, or even calculus, or just anything in just general. Now, differentiation, I feel like, doesn't really have enough attention to it, and I think the proof is actually it's not only simple, but you do see it does come together. Obviously, we know that there are several proofs out there that's more straightforward, also direct, but it's also well known for another thing as well, that you can also use proofs with right triangles and other similar related identities. You could use Euler's formula, differential equations, or even the power series representation to actually verify the following as well. So there's nothing more I want to say because hence differentiation, so we will be using some calculus, specifically since it's differentiation, so we will actually be having to use utilize the derivative to our discretion. But nothing more needs to be said, so let's actually just jump in. Okay, so by differentiation, we want to show the following. So how about I'll call an f of x function. We'll call the f of x the left-hand side of our equation. So f of x equals cosine square of x plus sine square of x, all right? Then if I take the derivative to both sides, so f prime of x, so here we would actually have to use the chain rule. In other words, cosine of x to the power 2, you could write it as that. So that simply is just the same thing as 2 times cosine of x, then subtract the degree by 1, then multiply with the derivative of what's in that input. In other words, this is the negative sine of x. Then we add this, so do the same thing here. So this will be 2 times sine of x, and then multiply with cosine of x. Then you'll see that this is just cancel each other out, so that means f prime of x is just equal to 0. So I'll just put it like this: f prime of x equals 0. So there's actually a little conclusion, or well, not really a conclusion, well, yes, conclusion. An observation we could say is that f prime of x equals to 0 if we take the function back itself, so integrate, for example, then we have to note, then obviously we see that f of x is actually some form of arbitrary constant, so we just call this c. So let's suppose that we just plug the trivial case back into here, so f of 0, for example. Okay, so f of 0 is simply just equal to cosine square of 0, add this with sine square of 0, okay? Then cosine of 0 is 1, so 1 squared, then sine of 0 is 0, so 0 squared, so that means it's just equal to 1. Then obviously you can clearly see that for the f of x function, that it's actually a constant function just like here. And then for any value at x evaluated at 0, then it's always going to equal 1 for any sort of real value x that you plug in. And so we can come to the conclusions and say that f of x is equal to 1, and so therefore we were actually done. Just plug back your f of x to the following. So we have that cosine square of x plus sine square of x is simply just equal to 1, just like that, and we are done. I know today's video is very short, but I feel like this this sort of proof with the differentiation especially doesn't really get enough attention, at least when I'm learning calculus, or well, just any math class in general. You ask anybody, I don't think, at least for my peers, I don't think they'd be aware that you can actually verify this by using calculus. So that's actually another way to put it, simply that this is actually another proof to use, one of the many proofs to verify this following. So yeah, that's pretty cool if you ask me.